Hi everyone, my name is Gautam Das, and this is your first lecture in mathematical methods. I'm going to be doing the videos for this course, and I know you all have your own goals and targets, so we're not gonna waste too much time in the introduction. We're just gonna jump right in, okay? But before that, I want you to listen to something very, very carefully. This course is not designed for notes, okay? I don't want you to take a single note while you're watching any of these lectures. Instead, I want you to pay full attention, and whenever you have a pen and paper with you, I want you to do every single question you see on the board. Okay? Regardless of if you think it's easy or if you think it's unrelated, does not matter. As long as it's a problem, I want you to have a go at it. Okay? Now, there are some questions that you have to do in order to play the video on, but even without them, if you do the other ones, that's what's going to make the difference, and that's what's going to cause you to succeed. Okay? Simple. Now, I promise you that's what's going to make the difference. And with that in mind, let's start the first lecture. Okay? So this one is on the introduction to differential calculus. Introduction to diff calc, short for differential calculus. Okay? Now, it sounds scary. You might have heard of calculus in other places, but it's really not. Okay, it's a simple topic. It's a fundamental topic in this course. And those of you who have seen this topic before know how important it is in this course. It makes up a good chunk of it, so it's important to have a good foundation here. But again, that's not something to worry about. This is a rather simple topic, and we're going to take you through it step by step. And by the end of it, you're going to have a strong foundation, and you're going to be able to tackle any problem that's given to you. Okay, so let's break this topic down into subtopics, okay? The first subtopic is rate of change. Second is rules of differentiation. And the third one is the applications of differential calculus. Again, sounds scary, I know, but it's not. It's really simple. Let's do this one at a time. Rate of change, okay? Rate of change. What is rate of change? Well, who knows? Okay. Well, let's just try and break it down first. Rate can be thought of as speed. Okay, so speed at something changing. Okay, right? Speed of something changing. That's the rate. Okay, and what is change? Change is for a value. It's just an increase or a decrease, right? So an increase or a decrease, all right? That's how values change. That's how numbers change. They either increase or decrease. Okay, so really, rate of change is the speed at which something increases or decreases, right? Simple. So let's think of it in an example. Okay, imagine you have a bucket, all right, and in this bucket, you're filling up water. Okay, you have this tap, it's on, okay, but before you turn it on, you already have 1 liter of water. Okay, even before turning on the tap. Okay, as you turn on the tap, eventually 30 minutes later, let's say, the bucket is now full of water. Okay, you've closed the tap, the bucket is full of water. Okay, and now it has 2 liters of water. Okay, now if we look at this, it's pretty clear that in 30 minutes, the water level has increased by 1 liter. So the speed at which the water is increasing is obviously 1 liter per 30 minutes. Okay, or you can say 2 liters per hour. Okay, therefore, the rate of change is also 1 liter per 30 minutes. Okay, because we just talked about it being the speed at which something increases. So the rate of change of the water is 1 liter per 30 minutes. Okay, simple. Let's do another example. Let's say Alex is doing a practice test. Okay, but before the practice test, he does 0 questions. Okay, 0 practice questions, and on the test, he then scores 45 marks. Now, we all know that is not a good score, and he failed. And why did he fail? Because he didn't do any practice questions. Okay, so I want you to think about that. But more importantly, he then does 10 practice questions and gets 75 marks. Now, that's how it works in the real world as well, more or less. You get more marks as you do more practice questions, okay? But for our purposes, the marks increased by 35 and the number of questions done increased by 10, okay? So for every 10 questions done, the marks increased by 35. Oh, sorry, 30. Okay, the marks increased by 30. So the speed at which the marks increase is 30 marks per 10 questions. Hence, the rate of change, 30 marks per 10 questions. Brilliant. Rate of change of marks equals 30 marks per 10 questions. Okay, simple. That is rate of change as simply as you can think about it. Okay, but if you look at these quite closely, you would realize one thing, okay, that whenever we talk about something changing, like a quantity is changing, for example, here the water is changing, like we're collecting water, okay, but it's changing with respect to something. In this case, the water is changing with respect to time, right? As the time increases, the amount of water we get increases. Okay, similarly here, okay, the amount of questions he does affects the number of marks, right? The more questions he does, the more marks he gets. So the marks are increasing relatively to the practice questions, okay? So these two quantities are also related, okay? So what we have looked at is a requirement of rate of change. That when there's a rate of change, there must be two quantities, okay? Water time, distance time, practice question marks, anything like that. There need to be two quantities and they need to be interconnected. They need to be related in some way, okay? So we've talked about quite a bit. So let's just summarize it here, okay? So rate of change, we'll put this all in one final definition. Rate of change is the speed of increase or decrease, speed of change of a quantity compared to another related quantity. That is important, related quantity. If they are not related, then we do not care, okay? That is it. That is rate of change in a nutshell, okay? Now, moving on, there is two types of rate of change, okay? There is your average rate of change and your instantaneous rate of change, okay? Let's look at average, and then later we will look at instantaneous. Okay, so your average rate of change is the rate at which something changes over a period of time. Okay, so for our example, when we look at the water, it increases over 30 minutes. Okay, so that is a period of time. Here, he does 10 marks or 10 practice questions and gains 30 marks. So over 10 practice questions over that period. Or like if you are traveling somewhere, how your speed is changing over the hour you drove, okay? So that is average rate of change. Now, it's pretty easy to calculate average rate of change, okay? It really depends on how it's given to you. Regardless, I think the process is pretty similar, and once you pick up on it, you start to join the dots very easily. So let's just look at an example. We have the amount of, let's say we have hours since it started raining, and the amount of water we collect, okay? Okay, amount of water. So when the rain starts, we have no water, obviously. When we have 1 hour of rain, we have 2 liters of water. And 2 hours of rain, we have 5 liters of water. Simple enough. Okay, now if we want to calculate the average rate of change over the 2 hours, what we do is we see that, well, the amount of water has increased by 5 in 2 hours. Okay, so naturally, on average, it's increasing by 2.5 hours or 2.5 liters per every hour, right? That makes sense. But let's just break it down and see what we did, okay? So what we did was we found this initial value and we found the corresponding function value, right? And then we found the final value and the corresponding function value, okay? And then what we did was we found the difference between the starting and finishing function value, and the starting and finishing in values. Okay, so the function values and the normal values. So this increased by 2, this increased by 5. Okay, so then what we did was we put them on top of each other, and we get 5 on 2 is equal to 2.5. That is what we did. Okay, simple enough. Now, this is literally what you have to do if you have to find the average rate of change. You find the start value, final value, start value, corresponding starting value, finishing value, corresponding finishing value, and then you see how much one column has increased by, see how much the other thing has increased by, and you put them on top of each other, and you get your answer. Okay, let's just try that with another example. This time with one of my favorite things, a function. Okay, the function f of x squared. Okay, now I want to know the average rate of change between x equals 2 and x equals 10. Okay, so I want you to have a crack at that and see how you go. Okay, now again, the hint is we do exactly as we did last time. Okay, so I hope you had a try at it. Okay, let's give it a shot. So like I said, we do exactly what we did last time. So we find the initial value, corresponding function value, final value, and the corresponding final value. We see how much the function increased by. We see how much the x values increased by. Function increased by 96, x value increased by 8. Okay, and then we put them on top of each other, and we get 22. It's a rather straightforward process. Okay, and that is basically all you have to do when you have to calculate average rate of change. Now, I said functions are my favorite, and now you'll see why. Functions are my favorite because you can graph them. Okay, so let's just graph this function. Why? Because it will help us visualize what we just did. Okay, it's important to see what's actually happening. So this is our function f of x squared. Okay, now whenever you're drawing a function, it's important to write the equation, the x-axis and the y-axis. Okay, so it's important to have that there, otherwise you lose unnecessary marks in an exam when you're trying to graph something. Okay, so now that we've done that, what we're going to do is we're going to note our points. Here's our first point, 2, 4. Here's our second point, 10, 100. Okay, these are our 2 points. Now, whenever we have 2 points on a graph, we can join them with a line. Okay, so let's create a line that passes through these 2 points. Okay, and whenever you have a line, you can find its slope, or you can try to. Okay, so that's what we're going to do here. So we have our line, and we're going to find its slope, which is denoted by n. Now, I'm sure you all know this. Rise over run. Okay, x2 y2 take y1 over x2 take x1. Rise over run. So we find the slope, and we get 100 from up 100 10, 100 point. Okay, and we get completely lost it. Okay, we get this from a 2, 4 point. Okay, and our final answer is 96 on 8, 22. Now this should be ringing alarm bells, in that it's the same as what we got here. Okay, now this is no coincidence. It's actually a fact that the average rate of change is simply like the average rate of change between 2 points of a function, any function, is simply the slope of the line connecting those 2 points on a function. Okay, I'll write that down. Average rate of change is the slope between 2 points. I always seem to forget that. Between 2 points is the slope of the line connecting those 2 points. Connecting those 2 points. Okay? Now, this is where we wanted to reach. This is the final conclusion that we were looking for from the start. But you didn't know that. I, as the tutor, did. And this is where we mark our end of average rate of change. Literally, this is all there is to it. Now, you've already covered your first topic, and that is not going to be enough. You're going to have to do some practice questions. If you have any doubts or concerns, they will be solved in there. Okay, so just watch the next word examples video, and you'll definitely learn a lot more. You will learn a few tips and tricks, and yeah, you'll be ready to do some questions on these. Was there anybody?
What to go?